So I'm delighted to be here to introduce our, they're coming back, our conservation plenaries this morning. You're going to be hearing from two scientists from very different hemispheres and backgrounds, each challenged with conducting research and using these for affecting conservation outcomes. There's no doubt our oceans are increasingly impacted by our activities, and the challenge of providing space for marine mammals to thrive in their habitat is a daunting and very often frustrating one. Within these plenaries and throughout the meeting, we aim to highlight research that focuses on affecting real conservation goals, as well as science and management that's been used both successfully and not. In doing so, the conference committee hopes to show you how much the society contributes to these goals while reminding ourselves of the many challenges that still lie ahead of us. Our first speaker is Dr. Asha DeVos. She's a Sri Lankan marine biologist and educator. She has a BSc from the University of St Andrews, a master's from Oxford University in the UK, and a PhD from the University of Western Australia. Her research program, the Sri Lankan Blue Whale Project, forms the first long-term study of blue whales within the northern Indian Ocean. She's currently a postdoctoral scholar at the University of California in Santa Cruz, where she's working specifically on reducing the problem of ship strike of blue whales in Sri Lankan waters. And she's going to be talking to us today about exploring the unexplored. Please join me in welcoming Asha.
All right, good morning, everybody. Oh, goodness. I guess the party was really good last night. Thanks, guys. So I do want to make a small correction to the bio. I'm not a postdoctoral researcher anymore. That's done. I actually now run my own nonprofit back in Sri Lanka. But we'll get to that shortly. To start off, I want to say thank you. I think I'm a little short, but thank you for inviting me here. It's a really big honor to stand here and speak to all of you, particularly given the incredible lineup of plenaries. I love the fact that they threw me into the mix. I am very different to the next speaker. I am certainly a lot shorter than he is, so they did think about diversity in many ways. My relationship with this society actually started about in 2009 when the International Relations Committee gave me a grant to attend the Biennial in Quebec City. It's also the last time I was this cold in October. But, you know, obviously I'm a glutton for punishment, so I keep coming back to Canada in October. But, you know, this year it was really nice because I got the opportunity to sit on that same committee to select which students could, you know, get grants to come to this meeting from the developing part of the world. And so that's kind of a nice full circle that I've come. And today I'm standing here on stage. And in the intervening years, I did apply to do, get an oral talk in, but never did, managed to just get posters. So I think it's fairly ironic that nobody ever allowed me to stand on this stage before, and today this is my first appearance, and I am a keynote. So there you go. So I'm going to tell you about my marine mammal odyssey, so to speak, with this incredible population of blue whales that I work with in the northern Indian Ocean. My story starts with this particular population. It goes back to 2003, when I was working aboard the research vessel Odyssey. And I think there's a number of people in this room who had the opportunity to actually be on this vessel at some point in their careers. You know, we were actually tracking sperm whales, but my first encounter with blue whales happened off the southeast coast of Sri Lanka. It was this incredibly beautiful day. We were tracking these sperm whales acoustically, and I was up on deck looking out for like signs of life, and just couldn't find this low, bushy blow slanted off to the left-hand side. But as I searched into the distance, I did see this incredible sight over here. And as soon as I saw this, I knew it was produced by an animal that was gigantic and had these incredibly powerful lungs. And I was super excited, so I called down to the captain and I told him what I was seeing and asked if we could shift off the transect and kind of go in that direction, which, you know, he gladly agreed to do, which is great. And so we started approaching this whale, and as we got closer and closer, I started to realize that it wasn't just one blue whale, but there was actually an aggregation of blue whales in a pretty small area. And obviously at that point, I started to wonder, you know, it's the largest animal that's ever roamed on the planet, with 70% of the planet to roam. And why was it actually just hanging out in this small area in warm tropical oceans? So I was fresh out of undergrad, and I started to think about what I'd been taught and what my textbooks had said. And what I'd learned was that large whales like blue whales will undergo these long-range migrations between cold feeding areas and warm breeding and calving areas. So immediately I got super excited. Sri Lanka is 5 degrees above the equator, so it's really beautifully warm and tropical. But I got really excited because I actually genuinely thought I was going to be the first person in the world to ever document blue whales having sex. So we get closer and closer, and then soon I realized that that's not actually happening. There's no whale penises around. There's certainly no whale babies around. And, you know, at that point I was thinking, what on earth is going on? And that's when we saw this. And so for me, this is a pile of blue whale poop. I'm sure many of you know this now. I'm extremely enthusiastic about it because it's beautiful. But apart from that, it is beautiful. But apart from that, I think the fact is that, you know, seeing that whale poop told me that these animals were feeding somewhere close. And, you know, I thought back again and I was like, no, but these are warm waters, and how are they doing that? And how are they supporting themselves in these typically unproductive oceans? And so that was actually my eureka moment. My career started with a pile of shit. And that's cool. You know, it's a great story. But, you know, it's really, like, it is important because it's what kickstarted the Sri Lankan Blue Whale Project. That's where, you know, I started to think, okay, I want to know more. This population is doing something different, and I want to unravel those secrets. So in the intervening years, I've actually had the privilege to, you know, I realized that, okay, so if I want to really understand what this animal is doing in these waters, why it's behaving the way it is, I need to understand a little bit about its environment, how that environment influences the animal. So I moved into an oceanography lab for my PhD, which was a huge learning curve. They speak in equations and numbers. I definitely don't. But, you know, I was able to show that actually the south coast of Sri Lanka is incredibly productive for that latitude because of the unique monsoonal circulation and how that interacts with our bathymetry. And it gives rise to these upwellings throughout the year. Also, through this work, I was able to show that the environment really does have a huge influence on the distribution of where we see these whales. That seems like common sense to you, but unfortunately, there is also misinformation that goes around, and you know there was a lot of misinformation about the fact that these blue whales were moving further offshore and because of the whale watching boats. And through this oceanographical work, I was able to show that no, in fact, it was to do with this crazy monsoonal system that had gone through in that particular year. We also know that this population of blue whales has a different acoustic dialect, and this is something that was actually unraveled by the Tulip expedition in 1983, headed by Hal Whitehead and Jonathan Gordon. And they defined this call, and it's called the Sri Lanka type call. These whales are also the smallest of all blue whales in the oceans. They're about 1/2 a meter shorter than their counterparts in the southern Indian Ocean. They're a type of pygmy blue whale. They breed 6 months out of phase with those particular whales. And we know this information because there was illegal Soviet whaling in our waters in the 60s. And we also know that they have different behaviors. They lift their tail flukes up before a deep dive more often than anywhere else in the world. So in Sri Lanka, we see it about 60% of the time. I know in the Gulf of St. Lawrence, for example, it's probably about 20% of the time. So this is like a photographer's dream. Not only do you get to sit around in shorts and look at blue whales, but you can also take pictures of their tail flukes, so it's quite special. So as I started to put these pieces of the jigsaw together, I started to realize that there was something particularly interesting about this population. They were unique. They didn't seem to migrate out of the region. We have documented them. Obviously, we know they're feeding. We document courtship, so we see ménage à trois behaviors. We see really small calves. And so I realized that, you know, there was something that needed to be done, particularly in light of some of the conservation concerns. And while none of the countries in our ocean basin have ever actually hunted whales or whaled out of these waters, like I said, there was illegal Soviet whaling in the 60s, and they took out almost 1,300 whales from a very limited range. So these animals are largely in the northern Indian Ocean. So taking out that number has impacts, obviously, on a population. But today we know that whaling isn't the biggest issue in our oceans for whales, and certainly not for this population. But instead, we face the big problem of ship strike. So if we look at a map of global ship traffic, you'll see that there's lots of lines, but all I need you to focus on is the yellow lines, because that's where you get the busiest shipping lanes in the world. So if we zoom in to the northern Indian Ocean around Sri Lanka, where I work, you'll see that it's the south coast of Sri Lanka is home to one of the busiest shipping lanes in the entire planet. It's the main artery through the Indian Ocean. Everything from Singapore to Dubai, two of the biggest ports in the world, travels through these waters. While global ship traffic has doubled since the 70s around these waters, it's actually quadrupled, showing how trade is changing, but also indicating that this problem is not actually going to reduce at any time soon. And if we zoom in a little bit closer and look at some of the data that's been collected over the years, the red lines are AIS data, so real ship movement data, and the black dots are where we've seen blue whales over the years. And what's immediately obvious is that the south coast of Sri Lanka, there is a distinct overlap between where we're seeing whales and where we're seeing ships. So obviously sites like this are not surprising. This is a blue whale that came into the main port in Sri Lanka, in Colombo, wrapped on the bow of a container ship. We know that it was killed on impact because it was a fresh carcass with signs of internal hemorrhaging. 12 days later, we found another carcass floating at sea with a massive propeller gash. Now, evidence like this is actually not always available because quite often carcasses will sink, they'll get pushed offshore, or they'll if they strand, particularly in our country where it's very hot and tropical, the carcasses will deteriorate really fast, and it's hard to tell cause of death. But we know these are not isolated incidences because research of the Californian coastline, where this is also a problem, has shown that for every one that gets documented, there's at least 10 that have gone undocumented. So it is an issue, and certainly the biggest issue we face in our waters. So obviously this has just become my biggest crusade, trying to figure out how we can mitigate this problem. With the knowledge that ship strike is all of our fault. We're all to blame because 90% of everything is shipped. And so how do we mitigate the problem with a win for the whales but minimum impact on the shipping industry? Subsequent to, when I started talking about this, I actually spoke about it on big media, and that was I did have some issues locally as a result of bringing this problem out, but it brought other people in to also do work in this area. And when we collect all our work, we see that, in fact, 90% of the vessels that are using this shipping route are actually bypassing Sri Lanka. They're not stopping into our ports. So if we can shift the shipping lanes about 15 nautical miles offshore, we can have big wins because we are separating where the whales and the ships are, or where the whales need to be, rather. It's allowing, obviously that's wins for the whales, but also the impact on the shipping industry in terms of fuel consumption is quite minimal. And then on top of that, there are other wins. For example, there's a whale watching industry that uses these near-shore waters, and there's our fishing fleet in Sri Lanka is defined as subsistence because it's very near-shore. So there's safety, obviously safety aspects to these stakeholders. And then it helps Sri Lanka to actually uphold some of the international agreements that we're signatory to. And in this case, particularly reducing coastal pollution, coastal ship-based pollution, in an attempt to increase the health of the communities that live in the coastal areas. So obviously this is like a quadruple whammy and sort of like a no-brainer to most of us. And then there's the 10% of vessels that do come into shore. They come near shore because they have to go into the local ports. Well, if, and this is an area we need to do more research on, but if we can ask them to slow down their speeds over specific areas that we know are important to the whales, then we can have a positive impact, because research has shown that if vessels travel at less than about 14 knots, impact is not lethal. And if we look at this map, this is actually the travel route of that vessel that hit and killed that blue whale that I showed you earlier. One thing that we managed to extract the data and look at the speeds that it was traveling at throughout its journey from southern India, Chennai, to Colombo, in our port in Colombo. And you can see that it far exceeded the 14 knots. It traveled at over 16 knots through the entire duration of its journey. So obviously, any animal that came in its path was doomed to die. So I guess, I'm talking about this work, and, you're probably thinking, well, okay, so what now? Well, I can tell you that I've been working with the politicians. I advise the ministers and the departments to try to enact these changes and try to look at, the fact that we do need to consider the protection of these species, particularly looking at some of these recommendations. But, and yeah, ship strike has been addressed in other parts of the world. There's a lot of great work that's happened. But when I tell you my science story, the one thing that's totally missing from it is actually the human journey. Sort of my challenges and what I face trying to get this work done, and why perhaps these lanes have not been shifted or speed restrictions already put in place. So while my story is obviously very tightly intertwined with these incredible creatures, I think that my work is not just about saving whales. I see my work as also an opportunity to show the world what capacity lies in the developing world, and the fact that we have talent, but perhaps we sometimes lack the opportunity. If you think about it, 70% of our planet is oceans, yet a disproportionate number of us actually work to protect it. 70% of our coastlines actually lie within the developing world, but where is the diversity at the global scale? Look around the room and you'll know exactly what I mean, right? How are we representing those 70% of coastlines? How are we allowing those diverse voices to come into our communities and to our societies? So I can tell you that, I believe very strongly in local solutions to address problems. I believe very strongly that if we want to change the current marine conservation trajectory, and if we want to save all these species that we're passionate about, we need local custodians on every single coastline who can empower, enable, and engage their people to create change. Let me give you the Sri Lankan context. Sri Lanka has been identified as a priority area for marine conservation because of its high species diversity, but also because it's in an area of high impact. Less than 1% of our oceans are actually protected. We are listed as one of the 40 worst funded countries for conservation. And in a recent study by the World Economic Forum that looked at gender gap, in 109 countries, there were 5 countries where gender gap has actually increased, and Sri Lanka is one of them. Now think about my story in light of what I've just told you, and think about what hardships that might actually bring to researchers like myself. The end of a 30-year war means that we're now experiencing unprecedented development and unsustainable development in the country because we want economic growth. We've shifted from a low-income country to a middle-income country. We want to stabilize our economy. And so, we're not really thinking about our natural capital, which is a really unfortunate thing. But we also lack the ability to sometimes address the challenges we face because there's a distinct lack of awareness about the oceans, but also a lack of capacity in marine conservation. And this is weird because Sri Lanka is this amazingly beautiful tropical island that has jurisdiction over 8 times more ocean area than land area. But when I started my career, when I started telling people, oh, I want to be a marine biologist, everyone looked at me and was like, what are you going to do? How are you going to use that? And that means you're just never going to come home. And that was never an option for me. But the thing is that my work has now, luckily through my work, because I am very determined to change the way people in our parts of the world engage with the ocean and give them the ability to learn as I learn. And as a result, my work has started a marine conservation movement in Sri Lanka. So it's really exciting because more people than ever before want to go into this field. So now I know I have the people with talent who have a desire and are excited, and now it's about making opportunity. And so I established Ocean Swell, which is my nonprofit organization, because I believe in nurturing this next generation of diverse future ocean heroes. I believe in enabling students from underrepresented nations to engage in marine conservation. And also, I believe strongly in engaging everyone in conversations about the magic of our world's oceans. So I want to tell you a few things that I've learned along the way, and I think that are really important to this community as well. And I hope that they can help us to think about how we can broaden and open our doors to more voices in the future. First of all, diversity is strength, right? Big business has figured this out a long time ago, and so that's why they have such an agenda to increase diversity in their organizations. Diversity allows for a better definition of the problem, wider range of solutions, more accurate prediction of outcomes, greater productivity, and of course, sustainability. Knowledge is the foundation of innovation. So if we're not allowing people, if we're publishing behind paywalls and we're not allowing people to have the building blocks so they can blossom and grow their research and be innovative, then we're actually stifling a large part of the population and a large part of the world. And so we need to look beyond these journals with paywalls. We need to think about being open access. And fine, if you want to publish behind a paywall, feel obligated to actually get your work out in a different way. A lot of people from places like Sri Lanka don't actually have access to the vast majority of journals that a lot of you will take for granted. And so we need to make it accessible in any way possible. Tell stories, share blog posts, whatever it takes, get the information out there. But apart from the scientific community, we need to start engaging with everybody else. Because I know for a fact, as a marine conservationist, I'm not going to save these blue whales on my own. They may never get saved during my lifetime, but I know if I've shared the knowledge, I've enabled people and I've excited them about the prospect of protecting this population, the work can go on, and even after I die, this work will not end. And so we need to learn to grow our armies beyond this community. We need everybody to get involved, and the stronger voice we have, the more collective our voice, the more change we actually can create for all these creatures. Let's also reassess how we measure impact. Impact shouldn't be about how many papers you published and what journal you published in, but it should be in the number of people that you have inspired and trained, and how your science is then also translated on the ground. And I think this is extremely, extremely important. I know for a fact that today I stand here, and there are a number of people in my career who have helped me and mentored me and encouraged me to go back and continue to live my dream. And I know those people look at me with a great sense of pride. I am their legacy, and your legacy can be a student. And a legacy in this form doesn't end with one paper, but it passes on for generations as I continue to work to pass on their goodwill as well. Let's do away with parachute science. So parachute science is when people from outside Western countries come into developing countries and do research and leave and then publish and just continue on their paths. And I say this because one thing is I've experienced it. I've had a lot of people come to me and say, can you get me a research permit so I can work in your country? I've also met researchers in our country because you have to have a local collaborator to do work in our countries. I've met researchers that are on papers, but when you talk to them, they have absolutely no idea about the work. And this means they're just faces and they're just names on a paper just for people to get permits. But there is no sustainability in this model because the minute these teams leave, nothing is left behind. So what I'm saying to you is, yeah, come, work in our countries, but think about how you're doing it. Consider the fact that you can bring in so much knowledge, training, infrastructure, and perhaps even funding. Come and train people. There's incredible talent where I come from. There's incredible talent in my region. Come and help people to stand up on their own 2 feet, because then you can have the confidence as you leave that country, that the work will continue, not for the duration of the project, but into the future, and that protection of that species will continue. That's incredibly important. And of course, that means that we have to sit down and reflect and think, what is it I'm trying to do? Am I trying to save the species and the oceans, or is it about my ego? Because if it's about my ego, yeah, I want to be the person on the ground. I want to be the first author on the paper. But if it's truly about saving a species, if it's truly about saving the oceans, then it's about sending more people out into the world to care and to make the change. And then I want to wrap up really by going back to that example or the story about me, actually, the irony of me standing here as a keynote today and never having got an oral presentation at the Biennial Conference. I was obviously tongue-in-cheek about it at the start, but I think there's a really important message there as well. And that is, we need to start thinking about how we actually judge people. And I don't have the answer for this, but I want all of you to start thinking about this. How do we judge people from a 200-word abstract? What are we looking for when we read an abstract? We're looking for the person's name, obviously, familiarity, what team they work with. Is it an incredible team that's done great work before? We want to see what innovative techniques they're using, what questions they're answering, what boundaries they're pushing. But what about those people we don't know, who are new voices, who we have no background information on? Maybe they won't have access to technology. And I can tell you, a lot of people that come from outside this circle, or outside North America, Australia, Europe, are usually working out of pure passion. Most people are working out of their own funds. They have absolutely no funding or infrastructure or support on the ground. They might be under political duress. And they might have other challenges that you have never thought about. Imagine my story. With my work, I've come under a lot of threat in Sri Lanka. I am a female in a male-dominated society. There was never a marine conservation movement when I walked in. We have a culture of extraction from the oceans, but never a culture of protection, and I wanted to change that on its head. All of these things worked against me, and if you read my abstract about some of the science I do, it may seem basic. It may seem like I've not pushed too far. But my backstory is so important to giving you context about what I'm doing. So try to think about that a little bit as we start to think about how we diversify. Unfortunately, when these researchers also are self-funded and they want to attend these conferences on their own steam, they'll come paying their own way because they don't come from big institutions. I mean, for me to come here, and I've been invited so few, but it costs about $3,000 for me to just fly here. There's all the other costs involved. So if someone tells me, well, your work is not good enough to do an oral presentation, but you can do a poster, the incentive for me to actually be here is much lower because I don't feel that the impact of my work will be so great. And so we start to lose these voices, and we start to make this community one where we hear the same voices over and over again. So I'm urging you today to think a little bit about the work that's happening, not in your backyard, but beyond. How can you assist? How can you be of help? How can you create your legacy, perhaps? If that's what you want to do, that's fine. But think about it. Think about how we can diversify and become more inclusive in our conversations, not just within this room, not just within this society, but also as we go beyond. And if we really want to save these incredible creatures that we have the absolute privilege to work with, never forget the privilege that we have to sit or stand side by side with the greatest giants that have ever roamed our planet. If we want to protect them, if we want to make change, it's time we started looking beyond. With that, I want to say thank you, and please follow the work at oceanswell.org. Thank you very much.
We have a few minutes for questions. Sure. Thank you, Asha. That was wonderful. We have a few minutes for questions. We can take one or two. We're also going to ask our plenary speakers to stay after the plenaries, so please come up to them afterwards if you have further questions. Are there any questions for Asha? There's microphones up the front, if you've got any. Do you want to repeat it?
How I started, actually, my story is long, and I don't think everyone wants to sit and listen to it. But my start began when I was about 6, and my parents would bring back secondhand National Geographic magazines, and I believed that I could be those people, and I believed I would replace everyone's face with my own, because at that age, ego is such a big thing. You don't really care. And so I had parents who, I was lucky. I come from South Asia where you're either a doctor, lawyer, or an engineer. But I had parents who told me to do what I loved and that I would do it well. And that's the one piece of advice I give everyone. That's the one piece of advice I hold closest to my heart. And that's what's enabled me to be who I am and do what I do and just really, like, as far as I can tell from where I come from, push the boundaries. So.
Thank you. Any more? Can't see. Well, if you want to catch up with Asha afterwards, please approach her then. We have something before you go. Damien organized an art exhibit at this meeting. It's down on the second floor, and there's a lot of wonderful artists to do with the marine environment down there. One of them, James Brown, actually gave us a few things that reach down deep. This is one of his art exhibits. It's a fish. You can display it anyway. And so that's from him as a thank you for coming.
Thank you, everyone. Thank you.
So our second speaker in our conservation plenary series is, I'm delighted to introduce, is Dr. Scott Kraus. So he's the Vice President and Senior Science Advisor for the Anderson Cabot Center for Ocean Life at the New England Aquarium in Boston in the US. He received his BA from the College of the Atlantic, his MSc from the University of Massachusetts, and his PhD from the University of New Hampshire. Scott has conducted research on marine mammals and turtles since 1980, and he is that old. And he's published well over 100 papers, scientific papers on marine mammal biology and conservation, fisheries, and oceanography. His experience in conducting science that informs management and his efforts to effect meaningful change to protect such species as the North Atlantic right whales are immeasurable. His skill in navigating difficult problems and connecting with all stakeholders to try to achieve a solution that will benefit endangered marine mammals is really remarkable. So today I'm really thrilled to have Scott come and talk to us about marine mammals in the Anthropocene, keeping endangered from becoming extinct. Scott.
And now for something completely different. So just to define some terms, the Anthropocene, of course, is that period, or I guess it's an epoch, in which humans are influencing the shape of the planet more than climate or dinosaurs or anything else. Excellent. So we're going to start on land. There are lots of ways you can go extinct. You could have a body part that is considered an aphrodisiac. That's really bad. You could be in the way. You could be in the way of suburbs, of loggers, of miners, farmers, or any other human activity. You could be good to eat. That's also a good way to go extinct. Or you could be in competition with humans. And marine mammals really are no different. In most cases, they were good to eat or they were just in the way. Disease, climate change, industrialization, fisheries, oil, drilling, a whole variety of things. It doesn't matter whether you're large or small. If you're in the way of civilization, bad things happen to you. What people mostly don't realize is that these extinctions can happen really fast. The Baiji disappeared within 30 years of the early warnings, and we're witnessing another extinction right in front of our eyes. Notwithstanding the heroic efforts of the Mexican and American scientists and managers, the vaquita is unlikely to exist in the wild any longer, and it is unlikely that there will ever be an ocean suitable for their return. Now, one thing that you should pay attention to here is that the vaquita went from 500 animals in 1997, or a little over that, to less than 50 in 2017. That's 20 years. That's fast. And there's a variety of other marine mammal populations below 500 animals that we should be paying attention to. And I want to particularly call out that are not on this slide, the southern resident killer whales, belugas in the Gulf of St. Lawrence, and I'm not calling out a whole variety of dolphins and porpoises around the world. So this is a urgent conservation deal worldwide. So that's totally depressing, right? Did y'all take your Prozac this morning? Fundamentally, we have too many people on the planet, and we know what we could do to curb population growth. We could educate and financially empower women. That's the thing that seems to work best at restraining population growth. But that isn't our job. So what can we do to collectively change the trend lines toward extinction in marine mammals? For 40 years, I've worked on the North Atlantic right whale, and I'm going to use that experience as by way of telling this story going forward. This species was probably on the brink of extinction in the early 1900s, perhaps less than 100 animals. It slowly came back from very low numbers to nearly 500 whales by the 2010 period. It is now, however, in the 6th year of a population decline. And the reasons for that are pretty well known, but the solutions are pretty complicated. And because right whale and the right whale management and the whole story of trying to keep right whales from going extinct is so challenging, I've been thinking about the difficulties of marine mammal conservation generally and wondering what we could do better. So the first thing I think we need to do is actually get better at telling our stories. We're really good at telling our stories to each other, but that's not what matters. In many people's minds, and I'm sorry to break this to you, the work that we do in this room is largely irrelevant. I'm sure you didn't get the memo, but Greenpeace saved all the whales 40 years ago by driving their boats between the harpoons and the whales. And that is the way many people in much of the world think about whales. So for our work in marine conservation to have any chance of success, it's essential that we have the support of the public and the politicians, and that they believe that marine wildlife and ocean health is important, even critical to their own well-being. And for that to happen, we need to get better at telling our stories about marine mammals in a way that the public relates to, that they can understand, that they can empathize with, and that they're willing to act on. So, for example, I think of whales as accidental farmers. Like Asha, I'm a lover of whale poop. And by accidental farmers, I mean that they feed, process, and fertilize vast swaths of ocean. There is plenty of literature on this. This fertilizing energy transfer is an ecosystem service with a huge economic value. Whales transfer iron and nutrients from the deep ocean to the surface, and the subsequent productivity is both critical to the fishing industry and it can mitigate climate change. It's a win-for. This is not a belief system. This is, as these publications show, these are the facts. And it's essential that this story gets out to fishermen, to politicians, managers, and the public. There's another way we can make the public care, is to show them that whales and dolphins live in societies. They have families, genealogies, social interactions, histories, and culture. They pass information on to one another, and they operate on scales that can boggle our little terrestrial minds. And this is not some new age fantasy, and it's also actually not even a statement about intelligence. These are the facts of life in the ocean for these animals, and people will like them. Making this case will excite people, and they can relate to because they can relate to social animals, and by extension, they can relate to the homes that they live in other words, the oceans. I also think we can improve the way we use statistics to tell stories about endangered species. Small populations suffer from small sample sizes, and trend detection in small sample sizes is really a problem. Managers like to have population estimates and trends within a 95% confidence interval. When you have small populations, you don't get those trends for 10 years or more. And so, you know, if you have comprehensive photo identification catalogs like we do in right whales, you can actually get to those trends a little quicker. In the new Richard Pace model, which you see in the lower right-hand side, which shows the trajectory of right whales from 1990 to 2015, you can see the decline, but it did take 6 years for that to actually develop and show up. And I think that given the challenges of detecting trends quickly in small populations and the speed with which bad things can happen to small populations of marine mammals, there's not really any scientific justification for allowing the take of any animals out of a population of less than 500. And that hasn't been the case in the United States, and it may not be the case elsewhere in the world. But when populations get that low, bad things happen quickly, and we need to be more precautionary. I do propose that there's a bunch of alternative strategies, and mathematical and statistical, that we could fall back on. There's several tools for looking at biological parameters, and I propose that we should fall back on first principles of biology. And if we measure these things appropriately, it gives you better power to detect rare species problems long before they become statistically robust in population assessments. And I'll give a few examples. So one alternative early warning signal are health assessments, because generally before populations go south, the health of the animals tends to decline. There are several methods, and this approach can now be considered mainstream marine mammal science. And they use everything from standard photographs, which nearly everybody takes now, to drones, which are measuring body condition and so on. And this is the example I'll use from right whales, where the graph on the lower left converts multiple visual measurements taken from the photo identification catalog into a score of 1 to 100. It's a Bayesian approach, and the 100, of course, means that you're absolutely in tip-top condition. And it is linked to events throughout the whale's life, which are shown in the lower panels, and I won't go into the details. But these efforts can now provide data and statistical approaches to look at the relationship between animal health and effects on population trends. So health assessments can provide critical information for managers, particularly when we looked at right whales. It turned out that female health was, or female reproduction, or reproduction generally, was particularly sensitive to female health. And the scores on the left-hand side in that graph show the health scores of available females that had calves in green and those that did not in orange. And there was a significant difference between the two curves, but more importantly, there was this threshold below which no female has ever given birth, and that's shown in the red line along the bottom. And of course, it's arbitrarily numbered 67. I mean, it comes out of the model, but you know, it doesn't really mean anything, right? It's kind of a low C or a high D if you were in grade school. So why does a health threshold matter? Because it allows you to assess the sublethal effects of human activities on reproduction. In the case of right whales, we looked at entanglement, and this is the work by Amy Knowlton and Rob Schick. It turns out that if you draw that threshold across the various categories of average entanglement health scores, that two things happen. One is that seriously entangled animals showed continued decline up to a full year after the entanglement ended, so that entanglement in fishing gear is much more consequential than people realize. More importantly, in many of those whales, their health scores fell below 67, which in the Rolland et al. Paper is the threshold at which calving stops. So given that 83% of all right whales have been entangled at some time, this is a life history event for which has serious consequences for population growth. And we're seeing that play out right now as calving in right whales has dropped to an all-time low. Another indicator of populations' reproductive health can be found in examining the percentage of available females that are calving. In right whales, the blue line shows a very nice increase as the population has increased over time. The number of available females has increased throughout the entire period since the early 1980s. But the percentage of those females giving birth has been falling through the same period. And one thing that you really notice here is that the percentage of calving females that were giving birth dropped off in the 2009 to 2011 period. There's quite a precipitous drop-off in the percentage of females giving birth, and that actually preceded the population decline and provided an early warning of population trends. Now, this population of right whales also has really high stochasticity in terms of calving, and I want to just make a point about that, which is that the absolute counts alone are not that informative, but particularly in a given year. These whales live a long time. They have a long reproductive lifespan, and but the relative interannual differences do provide indicators of issues with either female health or with habitat, and we should be paying attention to it. Another measure that is actually precedes population declines is changes in sex ratios. There are species for which the adult sex ratios are naturally skewed. There's some imbalance or something that's different than 1-to-1. But when sex ratios change over time, that's an indicator that either females are dying at greater rates than males, or male calves are being produced at greater rates than the baseline. Either condition warrants attention. And using the graph, again, from Richard Pace's recent paper on right whales, you can see that the weird thing about this is that they both sexes show this decline in population starting around 2010, but the divergence in sex ratios actually started 20 years earlier. And if that divergence, if we continue to have more males than females, you can actually see that's not going to end very well. All the boys will be standing around looking at each other. There's also there's some other indicators which I would say this is perhaps a really important one: unexplained increases in anthropogenic mortality. And it turns out our experience has been, and I suspect this is around the world, you have to do necropsies on dead animals to figure out what killed them. That really helps you understand the status of that species, and it helps managers understand whether any activities that they're doing is making any difference at all. So here the right whale activity, the right whale kills from human activity are shown in red, and we have in the United States, we have something called potential biological removal, and you can see that's the green line at the bottom. In other words, that's the allowable kills from the right whale population according to the U.S. law. So the point of this is that there's been a general increase in spite of the and we've never met the potential biological removal goal. But the thing that's important that doesn't show up on this specifically is that until 2009, 44% of the diagnosed right whale mortalities were vessel strikes and 35% were entanglements. And after 2010, that's reversed completely. The number of entanglement deaths has more than doubled over the previous decade, and shipping kills have have gone quite a bit lower, largely because of management actions taken by the United States along the coast of the United States to reduce ship kills. Also, it's important to remember that whatever you see dead, wherever you see it, is the animals that actually died. In the catalog, because we're able to track right whales from birth to death, we actually are able to track the number of animals that disappear each year. I mean, we give them 6 years to die so that we're pretty certain that they're dead. And that's a pretty good assessment. And so the purple bars show you how many animals remain undetected. The black bars are the dead ones, the ones we see on the beach or at sea. But the purple bars are the ones that disappeared. And that suggests quite with a 90% probability that they're dead. So this means that all of our assessments of the cause of death of animals, whatever the population is, widely underestimates the actual rates of death, and especially from human activities. One other story that I think we need to improve on is the question of marine mammal habitat, and this goes to the question of, what is it that we're going to protect anyways? You protect the whales and lose the oceans, you're not much better off. I think our definitions of critical habitat are way out of date. Small populations of marine mammals will require more habitat protections to reduce the risk of rapid extinctions. And because many are migratory, you have to deal with both breeding and feeding grounds and the migratory corridors in between. And given that the ocean industrialization is already widespread, it does not seem to be slowing down. What does that mean? Whoops. How do I turn it on? This is a nice animation. I'd really like you to see it. Oh, it doesn't show here. So critical habitat, in my view, is that it's not just about oceanography and food. It's where it's quiet enough to hear one another at ecologically relevant distances. It's where migration and foraging can occur without getting hit by a ship or entangled in fishing gear. Marine mammal habitat is three-dimensional, and anything that interferes with free passage and communication in those three dimensions is an alteration of that habitat. To claim that fishing gear or seismic exploration does not alter habitat is illogical. So we'll need to be more creative about habitat protection. It may not mean absolute closures to activities. Instead, let's imagine an ocean with quiet and slow ships, fishing without ropes in the water column, and aquaculture and wind farm sites that are both quiet and relatively benign. Now, that doesn't mean I am in favor of completely protected marine areas. But I think in this relatively busy ocean already, we're going to have to actually work more closely to develop ocean industries that have minimal impact and do not kill or disturb marine mammals and their habitat. Now, many people don't really understand the concept of an industrialized ocean, so to illustrate this, this is a very nice, benign chart of the western North Atlantic portion of the United States, from the Bay of Fundy down to Cape Hatteras. And we're going to take a little walk through it. That's the beautiful chart. Now here's the shipping activity. Let's add in the fishing activity. And now we're going to add in pipelines and cables. Okay, there are the wind farms. And now that's the military operations. Now remember that in this little exercise, I did not include dump sites, sewage outfalls, potential aquaculture locations, the proposed seismic exploration, and oil and gas drilling, deep sea mining, and a few other things. In other words, it doesn't get any less industrial than it is right now. Further, since we don't have enough to worry about, climate change is going to make the need for both rapid assessment tools and a lot more clarity on habitat requirements for marine mammals even more important. Ocean habitat characteristics are going to change, and animals will be going places they have not been previously. We're seeing a little bit of that now in Canada. Inevitably, there will be conflicts with industries that have not had to deal with those animals before, and management strategies to respond to that will need to be dynamic, and they'll need to be rapid in response to these changing animal locations. So this is a bit of a challenge, isn't it? How do we make progress on this? And although it seems counterintuitive, we have found that it is critical for scientists to work with all the stakeholders, including the fishing industry, wind utilities, the oil, gas, and seismic industries, the aquaculture facilities, and anything else that we come up with to put into the ocean in order to make them less detrimental. Canada's groundbreaking work on changing shipping lanes to avoid killing right whales took a long time, took a decade. But it is an example of what collaboration with industry can do to be effective. Now, the Baiji, the vaquita, and the northern hemisphere right whales serve as kind of an early warning to us all. Their losses and the ongoing threats to the survivors are threats to everyone who works and plays or lives in the ocean. We don't actually yet have a collective view on how marine mammals will survive or coexist with us in an industrialized ocean. Nevertheless, I think if we improve the way we tell our stories to all the the people who need to know, the public, the industry representatives, and the politicians and the managers, the next generation of marine mammal scientists will be able to bring a vision of coexistence much closer to reality. Or as Asha would say, let us build our armies. Thank you.
Thank you, Scott. I need to lower that quite considerably. We have just a few minutes for a question, if there's any questions now. And if not, we've got Asha and Scott who'll be up here up front, and you know what they look like now as well. Okay. Before you go, Scott, there are no questions at the moment. I'm going to give you, you also get, oh, you've got another one. There we are. It's really hard to see anybody in the dark. Please go ahead.
The question is about the 2010 inflection point in right whales and the development of new fishing line that's unbreakable. There's been a trend in fishing gear over the last 50 years to make it stronger and stronger over time. We've moved from hemp or manila to polypropylene to polyethylene and blended plastics. There are ropes that are ridiculously strong, like Kevlar ropes and so on, but they're not in the fishing industry. They're too expensive. So I'm not sure if you're talking about a particular rope, but I don't see much of that in the fishing industry at all. And the fishing industry is not responsible for the inflection point that leads to the downturn in right whales. It's partly responsible, but so is shipping and also a really reduced reproductive output. So it's a combination of things.
Also, just to mention, there's going to be a conservation series on Wednesday at lunchtime, more about the North Atlantic right whale, for all of you who are interested in hearing more about it. But in the meantime, thank you, Scott. And I don't even know what's next. So coffee is next, but I presume they're going to come and tell you about it.
Thank you so much.